Today is Thursday, May 7th, and our goal today is to be able to add and subtract like radicals. So in order to do that, I wanted to start off to recall combining like terms. So let's take a look up here. If I were to combine like terms, we talked about like going to a fast food restaurant through the drive-thru. Let's say if I go to McDonald's and I'm in the drive-thru and I have my friends in the car and I tell them I want a burger and 2 fries, and my friend wants 2 burgers but 1 fry, and my other friend wants 3 burgers and 3 fries. So I can only combine burgers with burgers and fries with fries. So when I give the order in the end, I'm going to tell her I need 7 burgers and 8 fries. And that's how you combine like terms. So taking a look here, I have 3x squared. I have to look for anything else that just has x squared. So here I have a negative 5x squared. So if you remember, those are like terms. So 3 minus 5 is negative 2. So I have negative 2x squared. Then I have a positive 4x and a positive 10x. So 4 plus 10 is a 14x. And then, last but not least, I just have minus 8. There's nothing to combine with it. So that's just like a little refresher, a little reminder. So let's look at the second one. Gets a little bit more challenging. So let's take a look here. Do I have anything to combine with this one? X, Y. So I have to find both X and Y. And there isn't. So this can just come down. Then I want to see here I have a positive 5, which is just a constant, and a positive 7, which 5 plus 7 is 12. And then here I have a negative 10y squared and a negative 2y squared. So negative 12y squared. And then if you look here, I have a negative 2x, but nothing to combine with it. So it comes down. And here I have a positive 3y squared. Uh-oh, I missed this before. Hold on. Let's go back. So I was supposed to add this. If you make the same mistake that I did, you're going to be like, wait, this one really matches with these other y squareds that I had. So let's actually fix how many y squareds I have total. So I have negative 12 plus 3 more gives me a negative 9y squared. So again, notice I could have more than one like term. Here's a y squared, here's a y squared, and here's another y squared. I almost didn't catch that. See, mistakes can happen, but as long as you catch it, then you should be okay. So that's our answer for combined like terms there. So now, as I keep going, I take a look here, and I want to know, well, how does that apply to adding and subtracting radicals? So notice this word that I put here. You don't hear it very often, but there's something called like radicals. So you see how this is a square root and this is a square root, and inside the radicand is 2? That means these are like radicals. That means I can just add it the same way as I would add 6x plus 5x, which you're going to tell me, hey, 6x plus 5x is 11x, right? So here I just have to do 6 plus 5, which is 11, and then bring down the rad 2. Okay, just like I would do this, if it was an x, it relates the same way. So your answer here is 11 rad 2. Look at number 2. Look at this radical. This is the cubed root of 7. This is also the cubed root of 7. So those are like radicals. So I can just do here 5 minus 3, which is 2, and leave that like radical. But then look at number 3. Are these like radicals? No. And can I simplify it? No. So they're not like radicals. and you can't simplify. So since you can't simplify and they're not like radicals, then this is the correct final answer, simplified. I can't add them. Oh, I like to box my answers. All right, let's take a look at number 4. Oh, take a look here. If you could recognize here, we have parentheses. We have a binomial and a binomial being multiplied. So we have to do distribution. So here I'm going to do 3 times 7. And then I'm going to do 3 times negative 4 rad 5. Oops, so let me move this down so I have a little bit more room. And then I'm going to do 2 rad 5 times 7. And then 2 rad 5 times negative 4 rad 5. So remember, you double distribute when you have 2 binomials. So 3 times 7 is 21. Now here, remember, when you're multiplying, if it's outside the radical, you can multiply them together. So 3 times negative 4 is negative 12. And then there's nothing to multiply with the rad 5. Same thing here. This is outside the radical. Outside the radical. So 2 times 7 is a positive 14 rad 5. Now for this last one, outside times outside, which is negative 8. And then inside times inside. Now remember, with multiplying, you actually do multiply the radicals, which is different than combining. Okay? Notice here, this is a perfect square. The square root of 25 is 5. And don't forget that negative 8. So negative 8 times 5, and I'm going to make this a little bit higher. So negative 8 times 5 is then going to be a negative 40. So really, this says the following. Okay, so this is what the problem is. So let's combine like terms. 21 minus 40 is going to give us a negative 19. And then negative 12 rad 5 and positive 14 rad 5. Look how they have a like radical. So I can combine them. I'm allowed to combine them since they have a like radical. So it's a positive 2 rad 5. So that is my final answer. I'm just going to make the rest of my work a little bit smaller so that you could see it. That's my answer right here. Always combine like terms and simplify as best as you can. So let's look at number 5. So remember, if I have this squared, that means this should be multiplied twice. So I'm going to write this, twice. And then here, now I need to remember to distribute. So I have rad 2 times rad 2. Then I have rad 2 times rad 3. Negative rad 3. Then here I have a negative rad 3 times rad 2. Hold on, I'm almost there. And then I'm going to have another negative rad 3 times negative rad 3. Very good. So those are the 4 terms that we're going to get when we double distribute here. So rad 2 times rad 2 is rad 4. Or you could say square root of 2 times the square root of 2 is square root of 4. Then a positive times a negative is a negative. 2 times 3 is 6. Negative times a positive is a negative. 3 times 2 is 6. And then a negative times a negative is a positive. 3 times 3 is 9. Because notice, all of them are inside the radical. So I'm allowed to multiply them together. Now the square root of 4 is 2. I cannot simplify any of these. And then here, the square root of 9 is 3. So now, let me combine like terms. Again, I just keep making it a little smaller so I have room. So 2 plus 3 is 5. And then a negative, 1 negative, and 1 negative of the same radical. It's almost like if I had negative 1x and a negative 1x, how much do I have? 2 negative x's, right? So here I have negative 2 rad 6. So that is my final answer there. And one more question and you should be good to go with the practice. It's here, number 6. Now if you look at number 6, these radicals are not like radicals. So we are going to have to reduce this first. So I'm actually going to change the color for a little bit. So here, I have to try and simplify it first to see, can I get them to be like radicals? So here I have a 6. Now, when I'm trying to reduce this, the question is, what's the largest perfect square that goes into 18? And if you know your perfect squares, 9 times 2 is 18, where the square root of 9 is 3. We have that rad 2. So really, this simplifies. 6 times 3 is 18 radical 2. All right, let's keep going. Let's try and simplify this one. I have this 4. Now, how do I get to 8? I have 4 times 2. And the square root of 4 is 2. And then 4 times 2 is 8. So far, what do you notice? They are like radicals. Ooh, let's see if the last one's going to work. So now the last one, you really have to think about the largest perfect square that goes into 72. So I'm actually doing some math on the side here and trying to figure it out. But I have to now think of the factors of 72. 1 times 72. 2 times what? 3 times what? If it works. So check your calculator and see what's the largest perfect square. So now here I have a negative 3 in the front. And now when I want to split this up, I actually find that 36 times 2 is 72. So the square root of 36 is 6. And I have the rad 2. And then negative 3 times 6 is a negative 18. So hey, take a look. We have another like radical. It just so happens to work out that all 3 of them are like radicals. It doesn't always work that way, but it did in this case. So think of it like saying, 18x plus 8x minus 18x. What happens here? So 18 plus 8 minus 18 is 8 rad 2, because this would be 8x. So that's why this is just 8 rad 2. So it's really important that you know how to simplify your radicals when it comes to a question like this, because if you don't know how to simplify them, you're going to get stuck. You're not going to know how to combine these. So I highly recommend, if you're struggling, that you go back to our simplifying radicals video, or when we learned how to simplify radicals, or even multiplying and dividing radicals, and go back and practice if you need to. But if you're ready to move on, I have here 9 questions that I want you to try. So now would be a good time to pause the video and try these 9 problems. I do have a copy of the worksheet on the lesson. Now I'm going to show you the answer, and when you're done, when you press play, you're going to see all the answers on my work. See you soon. Good luck. Okay, so hopefully you completed the problems and now you're ready to see the answers. I actually had them hidden on the next page, so just give me a second to bring them back up. It was a lot of work for me to do, so I didn't want to lose it. So there you go. And there are the answers to your 9 questions. So if you need to pause the video and check your answers, that would be great. I want you to keep in mind down here for number 8, there are 2 ways you could write the answer. You can write -1 times the square root of 7x, or you could just write negative square root of 7x. It's like the difference between writing either -1x or just writing -x. These are essentially the same. Okay? So if you have any questions, please make sure to message me on Schoology or on the Q&A discussion board. I'm actually just going to zoom in a little bit so that if you want to check each one individually, you can pause it at any time. Pause it at any time if you need to. Here's 4. Here's 5. 6. Just so you have an opportunity to see all the work and you don't miss anything. Okay? So I hope you guys have a great weekend. Take care. Bye.